This video will explain the purpose, functioning, and detailed construction animation for a screening chamber of a water treatment plant. A screening chamber is a structure in a water or wastewater treatment plant where incoming water first passes through screens that remove large objects like plastic, cloth, wood, leaves, and other debris. A simple screening chamber typically consists of a concrete structure designed to remove large debris from incoming wastewater. It includes an inlet pipe that carries untreated water into the chamber, and an outlet pipe that conveys the screened water to the next stage of the treatment process. Inside the chamber, steel screens are installed to intercept and retain solid waste on the upstream side, while allowing water to pass through. A perforated slab is provided above or near the screening area, enabling operators to stand and carry out cleaning safely. In some chambers, automated mechanisms are used to remove and separate the collected debris. The perforations in the slab allow excess water to drain from the removed waste, making handling and disposal more efficient. A more advanced screening chamber is designed for improved reliability and operational flexibility. It includes an inlet pipe for incoming wastewater and an outlet pipe to convey screened water to the next treatment stage. In addition, a secondary outlet, known as a bypass pipe, is provided to divert flow in case the main outlet becomes blocked or the chamber is taken out of service. Each channel is equipped with its own set of screens to capture debris. A perforated slab is also provided to facilitate safe access for operators and drain water from collected debris. Inlet gates for each channel are provided, typically with motorized controls, to regulate incoming flow during operation or isolation. Outlet gates for each channel are also installed to control outgoing flow during normal operation or maintenance. The structure is typically divided into two separate channels by a divide wall, allowing one side to remain operational while the other undergoes maintenance. Now let's take a look at how these screening chambers are constructed in the field. First, a layer of PCC is laid over the prepared ground to create a clean, stable, and level base. Next, the bottom layer of reinforcement is placed in both directions for the base slab, forming the primary tensile support at the underside. After that, the top layer of reinforcement is installed in both directions to complete the slab reinforcement, ensuring the slab can resist bending and cracking from loads and soil pressure. Vertical wall reinforcement dowels are then installed, projecting upward from the slab to connect with the wall reinforcement. For underground tanks, the walls are specifically designed to resist lateral earth pressure and any surcharge loads from above. Remember that depending on the size and depth of the chamber, additional structural elements such as columns or internal supports may be required to handle higher loads. Just like that, our foundation and wall reinforcement have been installed. Vertical dowels for the internal dividing wall are also installed at this stage to integrate it structurally with the base slab. Finally, the base slab concrete is poured. At the construction joint between the slab and the future walls, a water stop should be installed to prevent leakage through the joint, not shown in this video. The horizontal reinforcement for the walls is then installed, forming the main tensile support to resist lateral earth and water pressures. At locations where openings are required for inlet and outlet pipes, the reinforcement is carefully curtailed. Additional bars are provided around these openings to control stress concentrations, prevent cracking, and resist hoop stresses. For the side walls, the horizontal reinforcement is here cut and arranged in segments to match the wall geometry, including any recesses or indentations needed for installing mechanical gate slots. This process is repeated for each wall to complete the overall reinforcement layout. In the case of the central dividing wall, also referred to as a pier, the horizontal reinforcement is placed with particular attention to the locations where gate slots or openings will be formed. Due to its complexity, this reinforcement is shown separately at end of the video for further clarity. Dowels projecting from the slab are installed into the wall reinforcement to ensure proper structural continuity and to facilitate casting of the top slab at a later stage. Now that all reinforcement is properly placed and checked, the wall concrete can be poured. PCC is then poured at the bottom of the slab area with the required slopes and specially formed indentations for the gate systems. These recessed portions are carefully shaped to accommodate the installation of mechanical gate slots and screens, ensuring proper alignment and operation of the gates during service. Next, all gate assemblies are installed in their designated positions within the chamber. The gates are carefully aligned with the pre-formed slots and guide channels to ensure proper sealing. The remaining reinforcement for the slabs is then installed in accordance with the structural design drawings. Care is taken to ensure that the reinforcement does not obstruct the perforations provided in the slab for drainage and maintenance purposes. Once all reinforcement is properly positioned and inspected, the slab concrete is cast to complete the structural assembly. Pipework can now be installed at both the upstream and downstream sides of the structure to connect the screening chamber with the overall treatment system. Motorized operating systems are then fitted to the gates to enable controlled operation during service and maintenance. The screening units are also installed within the chamber to perform the removal of debris from the incoming flow. Once all mechanical and civil works are completed, the chamber undergoes inspection and operational testing to verify proper gate movement. After successful testing and commissioning, the screening chamber is finalized and ready for operation. Miscellaneous works such as railing systems, monkey ladders, access platforms, and safety walkways are then installed to ensure safe operation, maintenance access, and overall accessibility within the screening chamber facility. Let's take a closer look at pier reinforcement. The reinforcement is arranged in a particular way in pier conforming to its shape as shown. The bars are curtailed or given 90-degree hook at particular areas to fit the geometry. The vertical bars here are lowered for slab to rest. However, they could be raised if we wanted the slab to be integrated into the wall itself. The bottom bars were used as dowels into the bottom slab for connection. Let's move to the next reinforcement. For the wall, the story is similar. The reinforcement is arranged as per the shape of the wall as shown. The bars are curtailed at the indentations, or given 90-degree hooks, and secondary bars are provided at these indentations for countering stress. The overall wall reinforcement arrangement looks something like this. Let's now take a look at perforated slab reinforcement. Perforated slab reinforcement should be provided in a way that it avoids the holes. As you can see that our bars avoid every hole in the slab in both directions. Let's look at it through it in the translucent material. Let's finally look at the embedment indentations in our structure. The concrete and walls have indentations where steel gate slots are embedded. Our gate then slides in these steel-embedded slots. It should be leak-proof and well embedded. The PCC casted on base of slab also have indentation for gate slot to fit as shown. The screens also rest in another cavity provided at base of the structure as shown. This completes all the relevant details regarding a screening chamber. Thanks for watching the video. I hope you like it. Check more videos like these on the channel or visit our website for more content.